Hi, I'm Cheryl Leach. In this problem, I'd like to find the slope of the graph at a particular point. Well, let's take a look at the equation that I'm going to be working on. I'm going to be looking at 3x squared minus 2y plus 5 equals 0. And I already have the picture of the graph drawn for me. So if I want to find the slope, exactly what do I want to find? Well, I want to find the derivative. Because my equation has a mixture of x's and y's and it's not solved for either one, it's a little unclear whether I'm looking for dy dx or dx dy. Both of them are derivatives. However, because I'm looking for the slope is the change in y over the change in x of this tangent line. So, which version of the derivative am I looking for? Dy dx. So the slope is dy dx because I'm looking for the change in y over the change in x of my tangent line. All right, so I'm going back to my problem, and now I've established I want to find dy dx, but my equation's not solved for y, which is what I'm used to. One option would be to solve this equation for y. That would not be a hard thing to do. However, sometimes that's quite difficult, so we're going to use a technique called implicit differentiation. It allows me to find the derivative without first solving for y. I begin by taking the derivative of both sides of my equation. So on the left-hand side, my main operation would be the subtraction and the addition. So I will take the derivative of each piece individually. That's what those differentiation rules tell me to do. So to begin with, what's the derivative of 3x squared? Well, that's just a 6x. Next, I want to take the derivative of minus 2y. Well, that's a constant multiple of minus 2 that can be pulled out, but now I have to take the derivative of y. Now remember, we're differentiating with respect to x, so the derivative of y with respect to x is dy dx. Then, what's the derivative of 5? Well, it's a constant, so its derivative is 0. The left-hand side is now complete. When I move over to the right-hand side, I have another constant. The derivative of 0 is again 0. All right, so I'm completely differentiated here, but I would still like to solve for dy dx. So I'm going to isolate every term of the dy dx on one side of the equation. And it doesn't matter which side. In fact, in this case, I think it's going to be easier to move the minus 2 dy dx over to the right-hand side. So let's see what happens when I do that. I end up with 6x equals 2 dy dx. Now, sometimes you'll have multiple terms with dy dx's in, and you'll need to factor one out. But we're lucky in this problem because there's only one term, so I can go straight to the solving for dy dx step. All I need to do is to divide by 2. So dy dx equals 6x divided by 2. A little bit of algebra will tell me that the derivative is 3x. Now this will give me the slope at any point along my curve. In this problem, I'm interested in what's happening right here at the point 1, 4. So at the point 1, 4, my slope, which is dy dx, is going to be equal to 3 times x. The x-coordinate at this point is a 1. So my slope is 3. Now let's go back to the graph and see that this works. Here's my given point 1, 4. The slope of my tangent line is supposed to be a 3. Let's see if it is. From this point, I need to move vertically and horizontally to get back on the line. There are a couple of ways to do this. One way is to move down 3 units and then to the left 1 unit. So this length, we're moving down 3 and we're moving to the left 1. Negative 3 divided by negative 1 is a 3, just like the slope told me it was. You could also from this point move up 3 and to the right 1. That works as well. I hope this was helpful. Thanks.